This video is on alkanes. So we're going to talk about organic compounds in the alkane homologous group, which will also include alkyl halides, so halogens attached to alkanes, and cycloalkanes. So alkanes are the hydrocarbon family with carbon atoms that are bonded to each other with single bonds. The name of the alkane varies according to the number of carbon atoms. So that's really important. So that's the prefix that you're going to get. So we can make a table of members of a homologous series of continuous chain alkanes. They're called normal alkanes. And in this table, each member, so in your homologous series, each member would differ by one CH2 unit. So for example, you could have like CH4, and then you could have also CH3, CH3. So you've increased from here to here another carbon and two more H's. The names for all of these will end in ane. The prefix that goes with them is determined by your number of carbons. And we always draw them, not always, so we typically draw them as a straight line, although they're really zigzagged, which you'll see when we build them with model kits. So the general form is CnH2, or yes, H2n plus 2. So that's the format. So if you plug in the fact that there are, let's say, 3 carbons, so that would be C3, in an alkane, that would be 2 times 3, so 6 plus 2, that would be 8 hydrogens in this alkane. And this alkane would look like this, right? This is typically how we draw it. 3 carbons, 1, 2, 3 hydrogens on this first one, 2 on the middle one, and then 3 on the third. So there's your 8 total. But really, if you built it, it would look like this with a kind of zigzag, and your H's would still be here. All right, so the prefixes are as follows. Meth is for 1, eth 2, prop 3, bute 4, pent 5, hex 6, hept 7, oct 8, non 9, and dec 10. You'll have to know these. So the one I just drew, this would be because there's 3 carbons. So the prefix is prop. And because it's an ane, right, an alkane with only single bonds, this would be propane. And yes, this is like the propane you would buy for your gas grill, let's say. So the names here, there's a set of rules. They're set forth and decided by the IUPAC. Which is the International Union for Pure and Applied Chemistry. These are also the same group that determines like an element's name when a new one is discovered, that kind of stuff. IB expects you to name alkanes up to C6. So they really aren't probably going to ask you about like a heptane, for example, but honestly, they could, and I wouldn't be surprised. All right, so let's discuss the naming rules and then do some examples. So first thing you have to do is you have to find the longest chain and use that as your base name. We call that the parent chain. And remember, it might not always be drawn straight. You have to look at the longest continuous path of carbons. Anything attached to that is what we call a substituent. So these are these little groups or branches. So you number the carbons in your longest chain, starting with the end closest to a substituent. So whatever's closest to a branch is the end you'll start your numbering on. So this will allow that your numbering system will give your branches or your substituents the lowest numbers possible. For example, if I had a 5-carbon chain and a branch here, I would start numbering on this side right here. This would be my 1, 2, 3, 4, 5, 5th carbon, and my branch would be off the second one, versus if I had started on this side, that would give me a 4, which is not as low. So you're always going to go with the lowest one. All right, so you're going to name and give the location of each substituent. So this is going to work by you're naming your substituent based on your number of carbons. So if you have 1 carbon, the prefix is meth, but it's not methane. You take off the ane and you put the YL. So that would be a methyl group. So ethane, like 2 carbons, would be an ethyl group. 3 carbons would be a propyl group, etc. And then you do, we'll get to the number in a sec. When 2 or more substituents are present, you list them with their carbon number in alphabetical order. So ethyl would come before methyl. If there's 2 or more of the same substituent, so if there's 2 methyls, for example, that would be a dimethyl. You use those same prefixes. So di for 2, tri for 3, tetra for 4, same ones we did in our shapes. Prefix though are not for alphabetical order. So let's see, dimethyl would not go before ethyl. All right, and then the order is always your number of your location, and then a dash, your branch name, and then the name of your parent chain. So it says use commas between numbers. So if you have multiple numbers, you'd have a comma like 2, 3. And dashes are always between numbers and words. And there are no spaces in the name. So let's do some examples and check back at the rules as needed. So name the following compound. So the first thing I need to do is find my parent chain, my longest chain of carbons. So if I look at this, I'm just going to kind of trace a path right here. So if I start with this carbon or this carbon, it doesn't matter. They're both 1 before the branch. So let's just start here. So this, every time I get to a branch, I got to decide which path is longer. This one is longer. So here's my longest chain. And this is 1, 2, 3, 4, 5, 6 carbons. So my parent chain would be hexane. Hex for 6, ane because it's single bonds. So now I got to look at my groups here. I have 2 substituents, and they both have 1 carbon. So these are both named methyl. Okay. And so we're going to say dimethyl because we have 2 of them. So now let's look at where they are and number our chain. So we have, let's see, a branch. If we start numbering on this side, that would be 1, 2, 3, 4, 5, and 6. So we'd have 2 for our first methyl and 4 for our second. If I started a number on the other side, it would be 1, 2, 3. So then it would be 3 and 5, which would not be, 2 and 4 is lower than 3 and 5. So I'm going to start with my numbers for my substituents. So I have 2 and 4. So I'm going to say 2, 4, right? Those are my 2 locations. And then I'm going to do a dash. And I'm going to name my substituents. And there's 2 methyls. So I'm going to say dimethyl. And then I'm going to name my parent chain. No space here at all. So this would be hexane right next to it. So 2,4-dimethyl-hexane. All right, so let's try the opposite. Let's try to draw this one. I always like to start from the end. So I have 3-ethyl, 2-methyl-pentane. So I'm going to start with my parent chain and draw that first. So I have carbon, and I'm just going to kind of do big spaces between my carbons. 3, 4, 5. Okay. So now we have, I'm actually going to space this a little bit. All right, so now let's put my branches off. So it doesn't matter which side I start on because I could just flip it around and look at it from the other side. I usually just count from left to right. So I'm going to make my ethyl at 3, so that would be the middle one. So I'm going to do C, C. So there's my ethyl group. And then my methyl is at the 2. So if I put that here, top, bottom doesn't matter because you can get full rotation around a single bond. If you remember playing with the model kits, you could rotate those completely 360 degrees. So I'm just going on the top for space. Here's my methyl group. Now I'm going to put in my H's. Now I could draw this with a full structural formula. If I do that, I'm going to get H's all around here. It's going to get kind of messy. So what I'm going to do instead is I'm going to draw a condensed formula, kind of like the one that was in the example above. So I'm going to write in how many H's each carbon would have. So remember, carbon bonds 4 times. So this one would have 3. CH3. This would be just 1 H. This would be CH2, CH3, 1 H, 2 H's, 3 H's. So now they have a total of 4 bonds each. All right, so now let's talk about organic halides or alkyl halides. This is when one or more of your hydrogen atoms have been substituted by a halogen. So remember, this is your fluorine, chlorine, bromine, iodine, group 17. So they're named the same as alkanes. You have a substituent that's one of these halogens, and you just shorten the halogen name. So fluoro, chloro, bromo, or iodo. So, which is kind of fun to say. All right, so we draw the structure for this first one, for example. So if I have butane, that is 4 carbons. 1, 2, 3, 4. All right, so then I have 1, 2 difluoro. That means on the first and second carbons, I have 2 fluorines. So I can pick whichever side I want to be 1 and 2. Usually I do this side. Top, bottom doesn't matter because, again, they could rotate completely. And now I'm just going to add in my H's. Here would be 2, 1, 2, and 3. Okay, so the last piece is let's talk about cycloalkanes. These are alkanes that form rings, so they're completely like enclosed. So when you get smaller ones, cyclopropane and cyclobutane, prop means 3, right? But means 4. They are going to be very strained because that's like pushing your carbons really close together. The angles are less than the 109.5, which is your tetrahedral. So these are very reactive compounds because they really are not content the way they are. So when you name these, you have cyclo at the beginning. So it's written before. Substituents are named the same as your straight chain alkanes. And carbons are numbered again so that the substituents have the lowest or the smallest numbers. So really, if you have substituents, one of them is always going to be at 1 because if you're in a circle, you could start anywhere your numbering. Okay, so let's do some examples. So this first one, I'm going to count how many carbons I have. I have 1, 2, 3. I have no branches, and it's all cyclical. So this would be cyclo, single bonds, propane. Okay. My next one here then, I have 4 carbons here. I have no branches. So this would be cyclo, butane. All right. Now, one more thing with these, before I go on to the next example, is that they could be drawn in a different way. So this is a condensed formula, but we can condense it even more. And we could draw this cyclopropane as a triangle like this. And what this shows is that each point on your shape is a carbon atom. Right? So that would be one there, another there, another there. And it's assumed that all the other bonds are filled with hydrogens when they're not written. So your cyclobutane could look like this, and this is a much simpler, quicker way to draw it. So let's look at this last one then. We've got 1,3-diethyl cyclohexane. So just like the other ones, let's draw our parent kind of chain or ring in this case first. Cyclohexane. So I've got 6 carbons. 1, 2, 3, 4, 5, 6. Okay. 1, 3. So I'm going to pick which carbon I want to be 1. Doesn't matter which one you choose. It's just that's where you start counting after that. So an ethyl. So I'm going to pick this one. So an ethyl would be a CH2CH3 group. 2 carbons. That would fill up all their bonds. And then if that's 1, this would be 2, this would be 3. So another ethyl, CH2CH3. And then this carbon would have an H. This one would have 2. This one would have 1, 2, 2, 2. So if I did that condensed form like I did up here with the triangle and the square, this one, I would draw a hexagon, right? 6 points. And then I would do my CH2, CH3. And then here would be my third one, CH2, CH3. So this was a lot with alkanes, so make sure you look over this. We'll do quite a bit of practice in class as well.